Like Jess Barnes, geologist Katie Joy is fascinated by the far side mystery.
Because people hadn't seen the far side of the moon, we just made the assumption that the far side was the same as the near side. So Luna 3 turned our ideas on its head, and those ideas are still being turned on their head.
Katie is one of NASA's lead investigators, studying the precious Apollo samples to better understand the moon's mysterious past.
Because the moon's surface is very old, it can tell us a lot about history of the solar system's past. It can tell us about Mars, Mercury, Venus, and the Earth. Every time there's new technology, we can ask these rocks new questions, and that's why they're sort of the gift that keeps on giving, because they're always going to be available for us to look at with new ideas.
The Apollo samples continue to teach us about the moon, the Earth, and the rest of the solar system. But when it comes to solving the far side mystery, there's a problem.
With the lunar missions that have been to the surface and collected samples, we've only visited a very geologically restricted area on the near side of the moon. So in order to fully understand the moon and the far side composition, we really need to go back and collect samples from a more diverse region.
And with NASA's Artemis mission, aiming to return humans to the lunar surface in the coming years, Jess is preparing for a new batch of evidence.
We want to preserve that DNA, fingerprints, rocks as precisely as possible so that we don't lose any of that evidence. So before we go back to the moon, we really need to understand what's the best way to curate and keep samples safe and preserve them for future generations.
To get ready for these upcoming missions, NASA is releasing some crucial, untouched evidence from its vaults.
After Apollo 17, people soon realized that it would be beneficial to future generations to lock some of the Apollo samples away in special storage for 50 years. And now we're at the point in time when NASA has decided things have improved so much that we're now at a position to open those samples, use new technologies on them to answer past and new questions.
Now, armed with techniques impossible 50 years ago, Jess is one of the handful of people chosen by NASA to analyze these precious samples.
One of the things that we've been doing is using a particle accelerator to measure the oxidation state of sulfur in our samples. We're really looking at these samples forensically, and this is a really new technique that's been applied to lunar samples only in the last few years. So yeah, bring it up a little bit and we can do a slow scan.
This tool allows Jess to piece together the sample's history and establish how new evidence might be better preserved in the future.
We find that samples that were prepared 50 years ago contain a lot more sulfur than we see in samples that were actually stored frozen for 50 years. We're not quite sure why that is, but this is one of the things that we want to find out. Do we need to do something differently for samples coming back from the moon in the future?
It's a problem that must be addressed before we return for more evidence. Something Jess knows is critical if we're ever to finally solve the mystery of the moon's far side.